This video is a continuation of how to solve PDEs symbolically. It has been updated to show a very simple way to extract a solution from a single or double summation solution. Let's get started. We begin with a classic heat equation type PDE. Here is our initial condition, and of course we need two boundary conditions for them. We will solve it using PDSolve given those three conditions. And as you can see, our solution includes a summation of an infinite number of terms. Our goal is to create u of x of t with n number of terms in the summation, so we can use it for calculating values, plotting, and doing animation. The easiest way to create such a function is to use the substitution technique, which involves eval. First, we extract the right-hand side of our solutions, which is everything here. Next, we build our function out of two variables, chi and tau for x of t, and the number of terms. And we evaluate our solution where x is our valued chi, t is tau, and most importantly now infinity is now replaced by a value of n. Finally, we make sure that it completes the summation by asking either to evaluate it as a floating point or to select the value of this summation. Let's check for an example with three terms. This is the result you will get. If you do not include the expression value, it will stay in the summation format. If you prefer an expanded expression, here it is. This technique of doing the evaluate over the solution with respect to these three variables that are input, particularly the key one being infinity is replaced by the number of terms, is a simpler solution than using the copy and paste, although it doesn't produce as nice a picture. In addition, I don't think this is as efficient as the copy and paste technique. Let's look at another technique which is similar to copy and paste, but requires more maple steps. Okay, we continue the problem that we were working on before where we have this solution that includes a summation, and we'd like to extract out everything so that we can find the values at certain locations or even plot it. So again, here's our PDE, there was the initial condition, and our two boundary conditions for which we've solved it. The first step, as always, is we combine it into a single summation, and now our goal is to extract out this element, this expression within the summation. So let's do first by extracting out the right-hand side of our solutions. Now let's extract out the elements within here. That means the operand. So S colon equals OP of one, first one of S. And as you can see, it pulls out that term. The next step is to make a function of it. S is equal to make function of S, where the elements of or the variables are x, t, and n, because each term has a different value of n, close parentheses. Now we are ready to actually make our summation. So u is a function of x, t, and big N. Colon equals, it is a summation from n tab 1 tab big N of S of x of t of n, close parentheses. We can test this out with three terms, u of x0, t0, 3, and as you can see, it pulls out two terms because one of the terms is 0. This is not the most efficient solution. A more efficient solution can be found in the document associated with this video. However, I like this solution because it is easy to understand. Let's test to see if our solution makes any sense by plotting it. We of course have to set the constants to some value, k colon equals 1, colon L, big L colon equals 1 colon. Okay, so we will plot u as a function of x at t equals 0 for 20 terms, and x will go from minus L to L, and it looks like that. What about animation? Plot, dash, animate, open parentheses. It is a plot for which we are going to plot the elements u of x of t for 20 terms from x equals minus L to L. And you put colors in, color equals blue, close square bracket, and t goes from 0 to 2. Click on it, push play, and there's our solution. If you prefer not to do it step by step, but like to build a procedure, this procedure basically has all the steps in there, including combining everything on the right-hand side, extracting out the summation expression, making a function, and then eventually returning the summation for this particular solution. Again, we can test it u underscore underscore SOL of evaluate at x, big Y, big T for 3 terms, and we get the result that we expect. So what do we do if we get a solution that it's a double integral? Here's an example. I just made up this double integral, but that might be a solution that comes out of PD solve. So as before, we get the solution and we combine the solution so that everything is within the double. The next step is we build it. We can do the copy and paste technique. So z of x of y of t with n terms in the summation, colon equals, go over here, hit the double summation, N1 tab, big N tab, click on the double summation, and again, if you hit Shift tab, you can go back to the first one, N tab, 1 tab, big N tab, and then we copy and we paste. Let's see if we can get this to plot. We have to just evaluate for several constants. A equals 1, lambda, escape, colon equals 0.1, mu, escape, colon equals 0.1, and we'll say L is equal to 1. All right, so let's plot 3D, because x, y, of z of x of y of at t equals 0. We use 20 terms, comma, x equals minus L to L, y equals minus L to L, and we'll put the color blue in or something like that. Color equals blue. Now we'll try to animate this thing. So plots, colon dash animate, open parentheses, we're animating the plot 3D function procedure. Shift enter just for readability, open square bracket. We're doing z of x of y and now includes t for 20 terms. X equals minus L to L, y equals minus L to L, and the color is now Dodger blue. Close square bracket. And now we're going to do this for t equals 0 to 10. There's our plot. Let's click on it. Let's hit play. And we can see how it evolves with time. Again, just if you don't want to use the copy and paste technique, we have written out a procedure to do the process. And again, it combines everything from the right-hand side of our solutions. It extracts everything within the first operand of the first summation, and then extracts again everything in the second operand of the operation, makes a function out of it, and then reproduces the double integral. Let's hit enter. Let's hit enter. Let's try z solution for x, y, t for 2 terms. And you see it produces that result just as before. The document associated with this video, which is the same document associated with the previous video, has more details. As always, feel free to leave a question in the comments below.